Today's video will explain the decorator design pattern. Hello, I'm James Helfrich. The decorator design pattern allows us to apply an algorithm in any combination or in any order to a given context. This video will define the decorator design pattern and also explain how to use it in a variety of different contexts. Recall that there are three types of algorithm abstraction design patterns. There's the strategy, the template method, and the decorator. Today, we're going to talk about the decorator, which allows us to dynamically apply parts of an algorithm to a context in any order or in any combination. So the decorator design pattern has 5 parts. The first part is a task that we're trying to accomplish. The second is the abstract component. The third is a concrete component. The fourth is a decorator. And the fifth is the concrete decorator. Now, the task is that which the client wishes to execute. This is going to be a collection of different subcomponents or parts that we're going to execute in any order or in any combination. The abstract component is one node in a task list. In other words, we're going to build a linked list of tasks. A concrete component is an end or leaf node to the task list. This is how we know that we're finished. The decorator is an abstract class which allows us to execute a task, and the concrete decorator represents one task. So this is a lot to put together, so let's see how it works. The first component is the abstract component. This contains the task method as a pure virtual function. In other words, the abstract component doesn't have any attributes and doesn't implement any methods. It simply contains the interface. There's also a concrete component which represents the last task in the task list, otherwise known as a linked list. And usually the task method is empty, it does nothing. And it's going to be related to the abstract component through inheritance, which is clearly the case because an abstract component is clearly a base class and a concrete is a derived class. Now we're also going to have a decorator, which is going to represent something we're going to actually perform. And this is going to implement the task method. And the decorator is going to have an abstract component which points back to itself. In other words, this is going to be a linked list. It's going to have each decorator will point to another abstract component, and another one, until we get to the concrete component, which does not point to another abstract component because it represents the end of the list. Now, the decorator itself doesn't actually implement the task. Here, we're going to have a concrete decorator, which is going to implement the decorator, as well as the concrete decorator 2 or 3 or as many as we want to have. And each of these is actually going to have the task that we're going to perform. So how are we going to implement this in C++? Well, first of all, I'm going to create an abstract component, which is a new concrete decorator 3. And it's going to create a concrete decorator 3, which will then point to the concrete component, which is the end of the list. And now I'm going to create a new concrete decorator 1, and it's going to take the pointer to the concrete decorator 3 we had created. So it's going to put it onto the front of the list. Now I'm going to create a new concrete decorator 2 and the new concrete decorator 1. Now I have a linked list of different tasks I want to perform. 1, 2, 1, and 3. Notice how 1 is executed more than once, and I can include these in any order and in any number of times. So when I execute task, it's going to first execute the task of decorator 1, then of decorator 2, then of decorator 1, then of decorator 3, and when it finally gets to the concrete component, then it'll end the linked list. It turns out there's an easier way we can do this. Here we have the decorator class, which is an abstract class, and we have the pure virtual function called task, and I'm going to implement a concrete decorator 1, which is derived off decorator, and 2 and 3, just like before. And now instead of implementing my own linked list, I'm just going to have the component which is going to have a list of decorators, so it'll be any number of them. And then when I add task, I will simply append a new decorator onto my list. And when I execute task, I will iterate through my list of tasks and execute one after the other after the other. So much simpler and easier implementation, but has the same functionality and the same algorithmic efficiency. Let's take a look at an example. I like to make marinara sauce. In other words, Italian tomato-based sauce. Well, first of all, I'm going to have a class called Marinara, which can have a list of ingredients. I can have the prepare method and a couple private methods, which will handle measuring and chopping and cooking. Now, I'm also going to have a collection of variations because it turns out not all marinara sauces are the same. So I'm going to have a collection of variations, and this is going to be obviously the alternative implementation of the decorator. Now, I'm going to have pizza sauce, which is a little bit thicker. I'm going to have bolognese, which is going to be meat, and I'm going to have burro, which is going to be spicy. Okay, so these are my different variations. Now I'm going to have my add variation, which allows me to, from the base tomato-based sauce, I'm going to have the pizza variation, the bolognese variation, and the burro variation. So my add variation is going to have an enumeration. I want to like have a pizza, a bolognese, or burro, and then I'm going to push back onto my collection of variations. So how's this going to work? I have a marinara object, and then I want to add a variation pizza, and I want a bolognese and bolognese. So this will be a pizza sauce with double meat. And then when I call m.prepare, not only will it chop the vegetables and mix them and cook them and stuff like that, but it'll add the pizza variation and a double helping of meat. Let's take another example here, a little one more complicated. A store has a point of sale system which computes the price for a given purchase. This purchase includes the individual price of the item as well as a collection of special considerations. These considerations may or may not include tax, fixed discount due to the application of one or more coupons, shipping fees, and anything else. And of course, these adjustments can occur in any combination and order. So the compute price algorithm consists of a fixed procedure, summing up the individual elements, as well as a collection of procedures which may be applied. And this sounds like a good application for the decorator. So I'm going to say a system which computes the price for a given purchase. And so I'm going to have that compute price. And then it includes the individual price of the items. So I need to have something which is going to tally up the subtotal of all the different items. And I'm going to call this my subtotal. And it's going to have the collection of items I'm going to sum up, and it's going to compute my price. And my compute price abstract class will have a derived class called subtotal. So if the only thing I ever do is instantiate subtotal, then I will only subtotal without anything extra. Now I'm going to have a collection of tax or non-taxable items. So I'm going to say this tax, and then a fixed discount. And once again, I can have multiple different coupons applied. And then, of course, other special handling fees like shipping and things like that. Okay, I can make any number of these, of course. And these are all going to occur in any combination. So therefore, I'm going to have my adjust price, which could be one or more taxes, one or more discounts, one or more shipping charges. And these are all going, this is the base class from which the task, the fixed discount, and the shipping are derived. Now I'm going to do the original implementation of the decorator, which is a linked list. So my adjust price is going to derive off compute price, and adjust price will also loop back on compute price. So it's a linked list. Now, of course, I could do the same thing using the new implementation where I just have a list of decorators. And so here, once again, I have my compute price. I'm going to have an individual price items, and I'm also going to have my tax, my discount, and my other handling fees such as shipping. And this is going to all be based on the decorator, which is going to be adjust price. So adjust price will be my base class from which all the others are derived class. And my compute price can have any number of adjustments to it. Both of these work equally well. This is example 43.3 in the decorator section of the algorithm abstraction chapter of the software design textbook.